Exam 2. God, this is redox, that's pretty huge.
Redox.
Oh, this is awesome right now. Is it okay if it's a little hard?
Yeah.
Okay. I just don't want to freak you out, you know. You don't have to freak me out. I think this works. So we're going to balance this in basic conditions. Okay? All right, let's try it. First, well, let's get the oxidation states. I2 is 0. I'll do the easy one. This is -1. And this is easy for me, too. Okay, chromium. Plus
2? No.
Yeah, this is hexavalent chromium. Super toxic. Plus 6. Do I need to show you where I got this?
Yes.
Okay. If you don't know, I guess ask your friend, because they said no, so apparently they know how. Okay. So is this top one oxidized or reduced? This is reduced. It's reduced in value. This is increased or oxidized in value. What is the oxidizing agent? Iodine. What is the reducing agent? Chromium. Okay? Now let's do the half reactions. Split them in half. Likes were likes, just like on Sesame Street. I2, I minus. Okay? There are, and let's label these. This is the reduction half reaction. That's a super common issue. People switch these on the final. Okay? Make sure you know which one's oxidized, which one's reduced. All right, let's do the top one. Step 1, balance whatever's not oxygen or hydrogen. That's the chromium. You do that by inspection, 2. There's 2 on each side now. Step 2, balance the oxygen. 7 on the right, so you're going to put 7 what on the left? Water. Nice. 7 waters on fire, y'all. Okay, so next you balance the hydrogens with H+, and that is 14, H+. All right. Last step, you're going to balance the charge with electrons. The electrons are going to go on the right or left? To the right. And there's how many? 3. Good, I asked. Okay. Okay, what is the overall charge on the left-hand side right now? Plus 6, 2 times 3. On the right-hand side, before I do this. 12, so, right? 14 minus 2 minus 6 is 6, and this is 6. So it's 6 on each side. That's good. That's the same. All right, now moving on. Oh, another hint is I've always seen that the electrons and H+ are on the same side. So don't be crazy and put the electrons over here. H+ is here. All right.
I thought you balanced with hydroxide at some point with basics.
When you're balancing, yeah, hydroxide is for basic, but typically on a final, I mean, you have to read it carefully, but typically what we do is you balance the half reactions in acidic conditions, and then balance the final answer in basic conditions, which is what I'm doing right now. Okay. All right, step 1, balance whatever's not oxygen or hydrogen, that's the iodine, 2 on each side, you do that by inspection. Step 2, balance the oxygens, there are none. Step 3, balance the hydrogens, there are none. Step 4, balance the electrons. Electrons will go right or left side. How many? 2 electrons, because you got a 2 minus charge here. And also notice the electrons are on opposite sides. That's what it should be. Okay. And now, get a different color pen. I'm going to multiply the top by what? 1, and the bottom by 3. So there's 6 electrons to cancel out on each side. That's your intermediate. Now let's add them up. Okay, so on the left-hand side first, I've got 2 chromium, 3 plus 7 waters, plus 3 I2. There's all the reactants, all the products now. The dichromate ion, plus 14H plus 6 I minus. Okay, I think that's everything. Now, notice that I have this. I have H plus. Wrong. You need it in the basic condition. So this is where you do that part that you were asking about earlier. You've identified that there's 14. You add an equal amount of hydroxides to each side. So if there's 14 H pluses, you're going to add 14 hydroxides to each side to maintain the mathematical integrity. These here will make how many waters?
14.
Yeah, don't say 28, but 14 waters. That's going to cancel with my other waters, so that I'll have a net of 7. Anything else cancel? I think that's it, right? All right, add it up. We've got 2 chromium 3 plus 3 iodine 2, plus 14 hydroxides. I guess I'll put the state symbols in case you're asked. Aqueous, that goes to the dichromate. Ion, aqueous, plus 6 I minus, plus 7 H2O, liquid. Any questions? I think I'm done, unless I made a math error. Questions? What's the next one then? Oh, okay, there we go. How did I make 7 H2Os? This right here? Well, I had 7 there and 14 here. So I just subtracted 7 from each side. Anybody else? Okay, let's go. All right. Next. Oh my gosh. I'd say quantum numbers are pretty big. Net ionic equation is big. Titrations is big. Which one of those 3? Okay, I heard titration and net ionic equation. Which one's your favorite of those 2? Who wants titration? Who wants net ionic equation? Oh, it's kind of even. Okay, I'll try to do both. Sure, I was hoping it would not be even. All right? Sorry, I won't be able to finish. I just want to get as much as possible done here. For titration. All right, you're going to have an acid and a base. This is also typically a neutralization reaction. I can cross that off too. Sweet. Neutralization, gone. Titration, gone. Awesome. This is also a neutralization reaction. You're going to have an acid plus a base. You'll write the products, so they won't be too helpful to you except for balancing. So you're going to get a potassium sulfate in this case and a water. There's going to be, it looks like, 2 of those and 2 of those. All right. How are you going to identify as a titration? First with words. In words, you'll see the word titration, or synonyms thereof. Not synonyms, but variants of the word. Titration, standardization, or neutralization. One of those 3, or variation thereof. And then the other thing that's going to be weird about it is you'll be given information only about the reactants. Let's say we'll give a polarity there. Let's say this is 100 milliliters. Let's say this is 300 milliliters. Okay, so you'll be given information only about the reactants. You'll be asked about one of the 2 reactants. And there's a couple different ways that we could ask for, in this case, molarity, which is moles per liter. Could have asked you for volume if I give you slightly different variables, or mass, or moles. A couple different ways we could ask you, but the setup will always be the same. What you're going to do is start on the side you know information about and make your way to the side where there's a question mark. So, first step, this is your stoichiometry. What's the first step in any stoichiometry? Go to moles. So you're going to take the 300 milliliters and the 1 molar, which is 1 moles per liter. Do a little volume conversion. 1,000 milliliters per liter. This will get you to moles, because everything's going to cancel out the milliliters and the liters. You got moles. That's really your first step. What's the second step in stoichiometry? Molar ratio. I'll do that in a different color. Step 2, you're going to go to what you want with a molar ratio. 2 moles of KOH for every 1 mole of H2SO4. Okay? What's step 3? You're going to go to what? The requested unit. Okay, so in this case now, my moles of sulfuric acid are gone. I have the moles of KOH. I look at what I want. It's molarity. It's right there. It's moles per liter. I have moles, so I'm just going to divide by the volume. In this case, it's the 100 milliliters. So I'll put a big, I'll do different color. Black, I'm going to divide by 100 milliliters, and I have to do one more thing. Convert this to liters, because I need moles per liter. For molarity, that is, let's see, 1,000 milliliters per liter. So it's going to be something of this nature. In this case, we were going to molarity, but it could have been going to mass or volume or different things like that, depending on what was given. But it's just stoichiometry. Step 1, go to moles. Step 2, molar ratio. Step 3, go to the requested unit through conversion. Questions? Yes?
So in one of the problems on the practice final, you have a carbonate ion as a base. And I was just wondering why it was a base if it didn't have an OH on there.
Ooh, yeah, good question. That's it'd be interesting to see that, because I don't remember that question, but I believe you. There are things that are bases that don't have hydroxides on them. That's the short of it. So if we don't think you know that, probably we would try to tell you that in the question. I'm happy to look at it afterwards, though. Next. You'll learn that at 2B. It's going to be so much fun. Okay. What was the last thing I said? Net ionic equation. So remember, there are several types of reactions that you should be familiar with and be able to write the product. So I'm going to just show you a picture of them in my reader. 1 and 2 are less common. This is page 27 of my reader. These are less common. The ones that I would focus on, unless you're going for the real A+, but if you're going for A or so, you should be fine with 3, 4, and 5. The single replacement, the double replacement, and the combustion reaction. You should be able to write the products of all of those and balance. Okay? Only 3 and 4 would involve net ionic equations, where you have to cancel things out. So, for example, if you're ready, let me do one of those. If I gave you this, then I'd want you to balance it. You would call this what type of reaction? A single replacement. You have a metal with an acid. It would also work if you have a metal or anything by itself with anything ionic or acidic, and specifically a strong acid. So the magnesium will go with the chlorine because the metals form positive charges and it wants to go with something with a negative charge. Now, the hydrogen will go by itself. I'm not going to write it like this. I will write H2. Hydrogen is diatomic. It's a gas. That's something you just have to remember. How do I find the state symbol for that weirdo right there? Solubility rules, which will be given on the final. Basically, all halides are aqueous, except for a few exceptions, so it's aqueous. So that's from the solubility rules there. That, you just have to be born with that information. On my reader, it's on the next page, but for the rest of you, you're born with it. Now, I find things that have, next step for net ionic, find things with strong electrolytes. Yeah. Is this a strong electrolyte?
No.
No, it's a solid. How about that? Yes. Aqueous, strong acid, yes. How about this?
No.
Aqueous, ionic, heck yeah. How about that?
No.
No, gases, no. Anything that I underlined, I'm going to write out separately, the ions. Oh, I forgot the balance, by the way. 2, I think that'll do it. This one, Mg2+, and there's 2 Cl. Both of these have 2 Cl minuses. This also has 2 H pluses. Okay, then I cancel whatever's the same on both sides. Does anything cancel? Yeah, the Cl's look like they cancel. So then I will rewrite it anew and afresh, and this will be my net ionic equation. Okay? Now you can read the question carefully. We'll either ask you write the net ionic equation or leave it original. You know, just balance it and write it out. So we could ask for this or both. Just read it carefully. It'll tell you which one to do. All right.